Good evening, dear participants. Am I audible? Is my screen visible? Good evening. So, dear participants, can you please confirm? If everything fine, we can start with today's class. Thank you. Thanks for the confirmation. So with that we can start today's class. So what all we have seen in previous classes? We have seen about pandas and then we gone into the exploratory data analysis, right? So in yesterday's class we have seen one example how to do it. So we have seen some questions and few guys asked for the dataset link. So it is attached with the previous class YouTube description. It's done now. So if you want to download and perform that, what you can do is you can revisit that day 3 of this data science internship. Okay. So in the description you can find the link. It is a Kaggle link where you can download all the 12-month. Okay. Once you download it, you can do the processing and try to explore furthermore. Okay. So today and yesterday we have seen something about Numpy, right? So we have started. So in today's class we will try to complete Numpy. Once we complete that, we are going to go into visualization part. So in visualization today we will see about what all different visualization tools available, what all charts available. So when to use it, what is the use case. And in tomorrow's class, we'll go with the practical application. So how to do it with Python. So we are having some options like matplotlib and seaborn, which is very famous for the visualization purpose. So that's how we are going to continue with day 4 and day 5. So today we'll complete Numpy and go into the introduction of visualization. Clear? So today is day 4 of this data science Naan Mudhalvan virtual internship, and I welcome you all on behalf of pantech elearning. Okay. So continuing with Numpy. So we have seen about how to create a 2D array, how to create a 3D array, and yesterday we have completed with the indexing, right? How to take some element which is present inside a 3D element. So we have to go in the hierarchical order from 3D then into 2D then 1D, then that which element index number you have to mention. So if you know indexing, then it will be easy for you to go with array slicing. So they are same, right? So what you will be doing in a slicing, in a list or a string, usually in Python, we'll be mentioning the starting index and the ending index. So if I mention 2:5, so it will start from 2 and it will end one step before this 5. Okay, the ending index always one step before. So it will print till 4. So that's how the slicing works. Here you know how to slice a one-dimension array. So it is same, right? It is similar to a list. If you pass the index, it is going to slice and give you the result. And we'll do this, and then only the question arises, how are you going to slice the 2D array? So you know how to access a 2D array, right? Then it will be clear for you, easy for you to perform this also. So I'll show you. So we are going to create a 2D array first, x equal to 1D array first. Let me import numpy as np. np.array. So I'll create a list. Okay. Sorry, here a mistake. Now it's fine. Okay. So this is array. So if I want to slice it, I can go with, we'll do with starting with the 0th index. Okay. And ending till the 5th one. Okay, so it will give till 4 now here. So this is how you can slice an array. See here, till 4th index, which means 0, 1st, 2nd, 3rd and 4th. Okay, so this is how you can get it and slice a one-dimension array. So now the question arises, how are you going to do a 2D array? Okay, this is not visible, I think so. Wait a minute. Let me reload this. Okay, is it clear now? I hope it will be visible. So how are you going to slice a 2D array by using the indexes? Okay. So first you want to mention, okay, what is this one, whether this, what is a 2D array? It is a combination of one dimension array, right? So you want to mention which one dimension array you are going to go in. So I'll mention if I want to go and type this one, this will be the 0th index and this will be the first index. So I'll go with 0 and in that I want from 0 till second one. Okay, so it will take 0th, first and second, 1, 2, 3 if I mention this one. If I pass 1 comma 0 colon 3, it will go into this and start from 0th index till 8. Okay, this will be in the second index. I'll show you. So this is a two-dimensional array. So I'll print in y, let me pass 0 and in 0 I need from second index till end. So if I leave this empty, it means it will take till end, right? The 3 and 4, this is the second one. Okay, it is going into this one because I mentioned 0 first. So if I want to go into this one, I want to mention it is first here. Instead of 0, if I pass 1, it is going to take from the second index till the end. Clear how this is happening? No doubts? Any doubt? If you can have any doubt, please ask and make it clear. This is very simple. Don't get confused much. Okay. And there is another option also for you. So what you can do is you can perform commonly for both of these. If I want to take, for example, if I want to take the 4th index in this one and this one from both. So how am I going to do? Here the first one, what it is mentioning which one dimensional array, right? So I am mentioning 0 till 2, which means it will take till 1. So 0 and 1. So it is going to obviously take this one and in both it is going to get me the 4th element. Okay, element present in 4th index. Clear how it is happening? It is going to take 0 and till 2 I have given, so it will take one step before, which is nothing but 0 and 1. And in 0 and 1, in both of these, it is going to take the 4th one. So I can do this also. In both of this, I can go and take something which is present in first till 3. Okay. So we'll try to do this. So what I can do here, instead of mentioning any one, I'm going to pass this. I'm going to slice this. So this will give 0 and 1, both of this. And in that, I want the second element. The element which is present in the second index. So 3 and 7 I got the result. How am I got? This 3 is from the second index of this one and this 7 is from the second index of this element. Okay. So you can get it like from 0th index till second index. So if I run this, in both of this, it is going to get me this one. So this from 1 to 3 and this is 5, 6, 7 from both. So these options are available. Okay. Next, how can you get the shape of an array? So to do that, you can go with like Pandas we do, right? So here also you can pass dot shape. It is going to give you the shape of it. So I can go and do like this. Print y dot shape. So it is 2, 4. What does that mean? So I'll print y so that you can understand what this 2, 4 means. So the value 2 represents what it is representing. Any idea? 2, 4. Can you see it? It is like a 2 row 4 column, or you can otherwise define it is contains of 2 one dimension inside of this 2D. Okay, and the 4 represents the element inside in both of this one dimension. Okay, 2, 4. So it is split into 2 one dimension, and inside of it you can find 4 elements. So that's how this thing is describing. Is it clear till now? Can we go and look into the reshaping part, the next topics? Can I get a little bit confirmation from you guys? Please give me a thumbs up so that we can continue. You can go and check with the 3-dimension also. So I'll create a 3-dimension so that you can see how it is working. The shape property. So in Z, let me create np.array. Okay, this is the first 2-dimension, and I'll paste this one also. Print Z. So this is like a 3D which contains two 2-dimension, and inside of it you can find two 1-dimension, and inside of it that is 4 element. So I'll print Z dot shape. See here it is 2, 2, 4. So what does that mean? It is a 3D array, and in that it is splitted into two 2-dimension, and each 2-dimension is splitted into two 1-dimension, and each 1-dimension contains 4 elements. Got it? So this represents the number of 2D inside of the 3D. This represents the number of 1D inside of that 2D from here, and this 4 represents the number of elements present in this 1-dimension. Clear? So this is what describing here. We'll now see about how to reshape it. So all these things will be very useful and important when you go for neural networks and deep learning. So in that case, you have to pass inside the neural network. When you want to pass the data, you have to do some processing, and in that, if it is in different shape, then you want to go and do the reshaping. Otherwise, you'll be getting a lot of error there. So you'll be get lot confused. So these simple things, it will be very little, but when you apply that practically in that place, it is very important. So please make sure of these basic things clear, so that when we apply there, it will be clear for you guys. And now we will see how to reshape. So if you are having a 1-dimension, and if you want to reshape into a 2D, okay, then you can go with dot reshape, and you want to pass the shape you are going to do. For example, if I am having 10 elements, okay, so what is this 5, 2 means? Imagine I am having a 2-dimension array. If I go and ask the shape of it, it is returning 5, 2. For example, like this one. Here we got some shape, right? 2, 4. What does this 2, 4 means? It is splitted into two 1-dimension, and inside it got 4 element. So similar case, what if it is 5, 2? Which means it is splitted into 5 1-dimension, and inside of it two elements. Understood? And 10. Okay, so np.array, I'll pass a inside, print b.shape. So this is a 1-dimension. Okay, it is 10. Okay, only 10 elements. So what I'm going to do, I'm going to reshape it, b.reshape. Okay, and here I'm going to pass 5, 2, and I'll print c. Okay, so I'll tell you what will happen when you go with -1. So I'll have that slide later on, so please listen. I'll explain you step by step so that you can understand. See here, so now it is split into 5 1-dimension element, which means into 5 rows and 2 columns in that sense. Clear? Imagine if I pass this 6, 2. It is not possible because the element number we are having is 10, okay, totally. So you should be logically correct so that it can split equally. Otherwise you will be having error. Totally it will be 10, right? So no issues. And imagine if you want to convert a 1-dimension into a 3-dimension. So here comes the question, if you got a shape of 2, 3, 2, what does that mean? You are going to split this 3-dimension into a 2-dimension element, and each 2D contains 3 1-dimension, and inside of it 2 elements. Got it? So I'll take this, I'll do it here. For example, we are having 12 elements. I'll run this. Okay, here I'll pass 2, 3, 2. I'll run this. How this is happening? This is a 3-dimension which contains 2 2-dimension, and inside of it 3 1-dimension, and each will be having 2 elements. That's how we are reshaping it. Okay. And the next step is converting any array into 1D. So if you are having a 3D array, or if you are having a 2D array, so whatever it is, if you want to convert them into a one dimension, then you can go with -1. I hope it will be clear for someone who asked. So if you want to convert any array into 1D, you can pass -1 here. So it is obviously going to club them and give you into a one dimension. So for example, in C, now C is a 3D, right? So in Z, I'll create C dot reshape. Okay, I'll pass -1. So C is nothing but a 3-dimension array. Now in Z, if I print Z, it is going to give me a one dimension, because this -1 is going to club them and give you entirely together. See here, this is now converted into this one. Even if you are having a 2D or 3D, if you want to convert it into a one dimension, you can go with this option. Next we'll see how to iterate through one dimension, and then 2 dimension, 3 dimension. Can we see it, guys? How to iterate. What is iteration? Using for loop, using looping statement, going through one by one element. So in one dimension, it is like a string or a list. So you can go with directly, if you are creating a variable and go with for loop. The first time the A will be 1 here in this case. And the next time the A will be 2, it will print 2, and then next time it will be 3 and it will print 3. I'll show you. So now Z is like a one dimension, right? So for each in Z, so each is a new variable, I'll print each. So I'll be getting 1 to 12. Clear? It is iterating through a one dimension. So imagine you are having a 2 dimension. Let me go and take a 2D here. I'll copy it. I'll paste it here, and for A in Y, print A. Tell me, guys, what will be the result here? Whether I'll be getting each 1, 2, 3, 4 and 5, 6, 7, 8, or in which case? How will a for loop iterate over? So iteration happens. It will go and take the 0th index, and then the first index, and then second index, and so on. In a 2 dimension, what will be a 0th index? It is this one. And what will be the next first index? This will be this one. So I'll be getting 2 one-dimension element when I iterate over. See here, this is what my result is. So if you want to go inside of this, how are you going to do? I'll create a nested for loop. Okay, do you know, guys, about nested for loop? For B in A. Okay, now A is this one dimension. I know how to iterate over one dimension, right? So I'll create another for loop and I'll print B. So if I remove this print element, so I'll run this. So it is going to print this, and then 1, 2, 3, 4, then into this, and then 1 to this one, 5, 6, 7, 8. So if I remove this, it will be like, it will take A and go into that and print B alone. So if I run this, it is going to give me all the elements. This is how we can iterate over a 2D array. And tell me, guys, you would have guessed, how are we going to iterate over a 3D? What is a 3D? What will be in the 0th index? It is a combination of, I'll change these numbers here. Just for the sake, I'll do it. Okay, so for A in Z, print A. So I got two dimension. So I'll create another for loop. For B in A, print B. So it will go into that and print me. So if I remove this, it will be clear for you guys. Now I'll be getting all the one dimension separately, all the 4 one dimension. So what I can do is I can go and create for C another for loop, another nested for loop for C in B, print C. So this is obviously going to give me the entire thing. Clear? Is it clear, guys, how we are iterating over? Can I get a thumbs up? Can we continue with the next one? So we've seen about iterating through 1D, 2D and then 3D. So next will be combining arrays. For example, if you are having two arrays, two one-dimensional array, if you want to combine it, you can go with dot concatenate, and if you pass it inside like a tuple, it is going to combine them, okay, and give you the result. So we'll see this. X equal to np dot array, y is equal to np dot array, z equal to, using numpy dot concatenate, and inside I should pass a tuple of x comma y. I'll print z. Okay, so it is combined them directly. We got 1 2 3 4 5 6 7 8. This is what concatenate will do, and you are having an additional option where you can mention the axis. Okay, there is something known as axis as 0 and axis as 1, defining how to concatenate them. Axis equal to 0. So I'll run this one. So I got the same result, which means by default the axis has 0 only. Okay, row wise addition. If you want go with 1, you can go column wise. Sorry, you can do it in a 2D. For example, if it is a 2D, then only you can go with column, right? Because in a one dimension it is a single one. So if it is a 2D, then you can go with this one. So this is axis 1. If you go with 0, it is going to give you like this one, row wise and column wise actions. Okay, why we haven't got in a 1D? Because there is no column wise actions there. And next will be, there are two important things in NumPy. Okay, one is known as copy and another one is known as view. So there is a difference between these two. Please try to understand. So what will this copy do? What will this view do? We are going to do the same thing. See here, I am going to create an array and I am going to make a copy of it, and here I am going to make a view of it. And I am going to change something which is present in the 0th index. I am going to set it as 10. Here also I am going to do, and we are going to print both of it, and we are going to see what is the difference between this copy and the view. Okay, whether you are getting an actual copy or you are just viewing it. So with example you can understand it directly. I'll show you. So we'll parallelly create two things. X equal to np dot array 1 2 3 4 5 we'll create. Okay, and then in y I'm going to call x dot copy. So this is copy, and in x see here I'm changing the x only. In x, in the 0th index I'm going to set it to 10. Okay, I'll print x and I'll print y. You'll see the difference. I'm changing the x here, and when I use copy, it is created a different copy here. In y it is a new copy. Okay, so which means if you change x, it is not going to reflect in y, or if you change y, it is not going to reflect in x. Okay, understood how this is working? Copy will create a different copy, which means it is another one. It doesn't depend on x hereafter. And if I go with dot view, so what is this view is? Here also I am doing the same. I am changing the x alone, and we will try to do this operation. And see here, when you go for view, when I print it, it is actually changing. I am changing the x only, but y is also changing. How? Because that's what a view will do. It will make, okay, it is not making a different copy. It is just viewing what is x and give you that result alone. Okay, clear between the difference between these two? Clear? Can we continue? Okay, here comes the important part. When you go for some operations like OpenCV, where you want to do the image processing, where these NumPy zeros, ones and some mathematical functions will be very helpful. So can we start with this? Can I get a thumbs up? Okay, so there is something known as NumPy zeros. Okay, Fine guys. So there is something known as, okay, I'll explain the view once again. So there is two options, one is known as copy and another one is known as view. So what is this thing is, if you make a copy and store it another variable y, so now y is the same copy of this, but it is stored here in y. So it is not dependent on x, which means if you change x, it is not going to reflect in y, because y is now a different copy. When you go for view, so view is not actually making a copy, it is just showing you what is x. So whatever changes happens in x, it is going to reflect in y also. Okay. If you change some other element, for example in the first element, if I pass it as 20, it is going to be the same one in x and y. And with numpy zeros, so in numpy zeros, there is an option for creating zeros. So you have to mention the shape, and in that shape, it is going to give you only zeros. So tell me guys, if you have any idea with the image processing or with the color perception, if it is 0 everywhere in the image, what will be the color of it, whether it is a black or white? Tell me guys. So in that place only we are using these zeros actually. So if you pass 3, 3, it will create 0 in all the place in the shape of 3, 3. And you have to mention the data type. When you go for creating the image, it will be the data type, it will be different. Okay, you want to pass the image, okay, in that case you will be getting its image. So now tell me guys, what will be the color of this one? Zeros. Yes, correct, black. Okay, and 1, what will be the color of 1 then? Using np.zeros here. Okay, I have to pass a tuple with shape 3, 4 if I pass, and the data type, I'll pass it as integer. I'll print x. Okay, it is in the shape 3 row 4 column. Okay, 3, 4 zeros only. And similarly, if you want to go with 1 everywhere, what is the color of 1? If it is 1 everywhere, it will be which color? It is white. Okay, so np.1, which will actually create 1 in all the place in the shape you are giving. Okay, it's 1 everywhere. Clear? And imagine if you want some other numbers in the shape, you want to give a number and you want that shape, then you can go with numpy.full. So in that you have to pass the shape and the number you want. If I pass 7, it is going to be 7 in all the places. First I have to pass the shape, for example 7, 6, and in that the number I want is 19. I'll print z. Okay, so this is how you can do with numpy 1, 0, full, and then you are having range option in Python, right? But in numpy there is another one also. So when this will be useful is when you are going with many numbers like lakhs. Okay, as we know, Python is very slow. When you go with numpy, it will be very faster when you compare. So here you can go with range. So you have to pass two things, the starting and ending index. So it is going to give you that. And if you want to pass a step, you can do that also. If the step is 2, it is going to 2, 4, 6, 8 in that manner. A range, okay, it is print x. So it is going to give me till 17. It is same like the Python range, and if I pass 3 here, it is going to give me 3 steps, 2, 5, 8, 11, 14, 17 and so on. Okay, and we'll see some mathematical manipulation. Okay, can we start guys? For example, if you are having 2 different arrays and if you want to do some mathematical task with it, for example, you want to add those and get the result, subtract, multiply and divide between these two. How are you going to do it? You can go with numpy add, subtract, multiply and divide. I'll show you. A is equal to np dot array b equal to np dot array okay. So someone is asking which is better, whether it is numpy array or tuple. So based on the requirement, so what is the main property of a tuple? When you have list, when you go for, where are you going for tuple? What is the property of a tuple? The thing with tuple is immutable, but array is mutable. Anyway, numpy array or list is mutable. So based on your requirement only, you are actually need to go that. Okay. If you don't want the user to change something, the sequence you are having, then you can go with tuple, which is immutable. Or else if you want faster to do things, then you can go with numpy array or list in that comparison with tuple. Okay. So I'll print np dot add. I'm going to pass this a comma b, np dot subtract, np dot multiply, np dot divide. So this is the result. So how this is happening? See here, this 0th index and this 0th index. 1 plus 5, 6, we got it here. 2 plus 6, 8, we got it here, and this way. So similarly, when you go for subtraction, 1 minus 5, it is minus 4, and it is same in all the cases. Then multiplication and division. Okay. And next, we'll see some other things. There is no sum and mean. So if you want to take the sum of these two, okay, in a 2 dimension, or if you want to take the mean of it, and you are having two options. One is axis 1 and axis 0. So how are we going to do that? So I'll show you. With that, you can see the result, what it is. Okay, x equal to np dot array. I'll create a 2D 1 2 3 comma 4 comma 5 6 7 8. And for example, if I'm going with print np dot sum, okay, and I'm going to pass x comma axis equal to 0, and I'll print np dot sum, and where I'm passing x and axis as 1. I'll run this. See here how this is summing and how this axis as 1 is summing. If I mention axis as 0, what is happening? It is taking this both. Okay. So this one will be 1 plus 5 6, 2 plus 6 8, 3 plus 7 10, 4 plus 8 12 in this order if the axis has 0. If I go with axis as 1, then what is actually happening? It is adding all these things. 1 plus 2 is 3, 3 plus 3 6, then 4 10. Okay. When you go with here, it is going to add all those and giving me 26. So this is how the axis 0 and 1 happening. Sum is the adding everything and give you the result. If you want the mean value, then you can do the same, and we'll get in this order only. Okay. So mean is like it will add all those and divide by the number of occurrence. So this is what the result we got. 1 plus 5 is 6. So divided by 2 3, then 4 5 6 here, then here 2.5 and 6.5. And then finally, in Python we are having random, right? So here also we are having random. So with that you can go with np.random.random. So it is going to give you in this, between this, in this shape it is going to give you. Remember guys about random. So if you just call the random, what it will do? It will give you float values, right? If you want integer, you have to go with rand int. And this is a shape, 2 comma 4 is the shape here, so it will be float numbers in this shape. And if you want integer, you have to go with rand int, and you want to pass what is the starting and ending number. So here I need between 10 comma 100 in the shape 3 comma 5. Got it? We'll see both of this, and then we'll see linspace. With that, numpy will be over. X equal to np.random.random, and in this I'm going to pass a tuple 4 comma 4. I'll print x. See here, it is a float value in the shape 4 comma 4. It is similar like Python random. We'll also get that, right? If you want random integer, what you have to do, you have to go with rand int, right? And you have to pass the range. So in which range? So this is going to give you, wait, we'll try to pass the range here. For example, 10 comma 100 comma in the shape 4 comma 4. Print x. For those who don't know what is random, random is a module from Python which will actually throw you random numbers. So it will be different numbers. You can even call the choice, where it will give you a random choice. If you are passing any 3, it will take 1. You can get the result. Or if you want numbers like this, in between 10 comma 100 in the shape 4 comma 4, how this we got this number? This is the random number. Between that, it is based on the algorithm, it will give you just random numbers. And we got it right, between 10 to 100 in the shape 4 comma 4. And next will be line space. Final one. So what this line space is, you have to pass 3 things. First one will be the starting number, second one will be the ending number, and 5 is how many you want. Between that, equally how many you want. So if I pass in x, for example, x equal to np dot line space, okay, 10 comma 30 comma 5. I'll print x. See here, it's splitted into 5 parts between this equally. Okay, if I pass 10 comma 100 into 5, see here, 10, 32.5, then 55, then 75.5, 100. Want to split it into 8 equally, then it is going to give me that 10, then 22.857. So how it can accommodate, it will do and give you the result. That's what this line space is. So that's it guys with Numpy. So the practical application of Numpy we'll do with the data analysis. When we go with the data set, we'll see how we are going to apply that, and in the machine learning project too. Okay, these will be the basic things you want to know in Numpy. So with that, some other additional things we'll see when we see about the working with the data set. So tomorrow's class is visualization. Today I am going to take about the art. Okay, so what are the different graphs available, so how and when to use it. So with that we'll complete today's session, and in tomorrow's class what we are actually going to do is we are going to see matplotlib and seaborn, where we can use and get these kind of charts. And in day after tomorrow, which is Monday, the day 6 class, we are going to see a exploratory data analysis project in that entire class. So that will accommodate, we are going to take a data set and do with Pandas, we'll do all the pre-processing and try to get some answers for some question along with the visualization. In yesterday's class we have done with the sales data set, right, but it was only with Pandas. So in day 6 we are going to apply it and get some of these graphs which will be visually helpful for us to understand about the data set. Okay, we'll start with the visualization. Can I get a thumbs up guys? Can we start? Yeah, the assignment I'll give you in tomorrow's class. Tomorrow is day 5, I'll give you the assignment. So regarding the previous Python internship project submission link, so I'll make sure tomorrow is the last date for the submission, right? So I'll ask my team and make sure you will receive, okay? There will be some technical issue, so I'll ask them to clarify it. So starting with visualization. So why we need it? The art of visual storytelling. So if you are giving in text data, otherwise if you are giving in visualization, what will be attractive and easy for you to convey the message? Visualization will be better. So the human visual perspective is very easy for you to understand. You will grasp it within a second when you see an image. Instead of going with numbers, it will be difficult for you to go and see everything. So data visualization is an essential part for data analysis and data science because it helps to communicate complex information and patterns in a simple way. So by representing data visually, you can easily identify trends or pattern or outlier that may be apparent from the raw data. Okay, it cannot be viewed when you see the whole data set. But if you go for visualization, you can see what all things, okay, you can understand it. And visualization also helps you to explore and understand data more effectively, allowing you to make better informed decision and communicate your finding to others more clearly. When you see in the data analysis part, this visualization will help you to analyze the data and see all those things. But when you go for the data science, so what we are actually doing in data science, we are converting a raw data and taking actionable insights from it. So what you can do with that data, you can take insight, and if we do this, this is what happening. So if you do this one, this will be better. This is what I predicted. So in the end, what you are actually going to do, if you are become a data scientist, and if you are doing some task, you are be giving some task and the stakeholder is asking you to give some information. So in the end, you are going to explain to the stakeholder or the owner or the client, you are going to explain. So what is the output from the data science project you are doing? So in that sense, you want to convey the message to them understandably and clearly. And in that also, this visualization is playing an important role because it is very important. With that, you can easily convey message. So that's what the whole idea behind this visual storytelling is. And these are the commonly used graph types. You would have gone through it. There are some other things also, but these are the most common graph types. Line graph, scatter plot, bar plot, histogram, pie chart, heat maps, and box plot. Okay. So now comes the question. So choosing the right type of graph. So for which one I should, if you go with like in different manner, it will be completely destroying. So you won't analyze or understand anything from the visual part. So you have to go and choose the right type of graph. So it will be, you have to consider some factors. For example, the type of data or the type of analysis you are going to do. What is the message you want to communicate? Okay, and your intended audience. So based on these three factors, you are going to do it. So we'll start seeing by one. So we'll see some things about these graphs. With that, we'll complete today's session. Can we see it, guys? Can we go on with it? Okay, so the first type is line graph. So a line graph displays continuous data. What is a continuous data? It is continuous. So for example, if it is a stock price, based on the time, it is continuous. For example, it is going from every day from 1 to 30 days. It is going, how it is going? It is going up and then down, and then it is increasing. At some point it is decreasing. So when, in which day it is decreasing, in which day it is increasing. Okay. So how this is happening? A line graph displays a continuous data. If you are having a continuous data, you can go with line graph. And every line graph consists of data points that are connected. So it is like connection of data points. If you are having 5 points, you are going to connect it and draw a line. And the purpose of connecting the line is to help illustrate a trend, for example, a change or other pattern. For example, if it is increasing or then it is decreasing and so on. What is the use of a line graph? When you want to show a trend over time, for example, house price or stock or rainfall over the time, in which month. So if you want to display something like this, you can go with line graph. Clear about line graph? So the next one will be bar graph. So a bar graph represents discrete data with rectangular bars. What is a discrete data? For example, in yesterday's EDA we have done, right? And in that we have seen about like which state sold the most product, and I hope we saw California or something, San Francisco sold the most. Okay, San Francisco. So in that, if you want to represent, for example, 10 city, if you go with bar graph, you can see, right? So if this is the highest one, which means this sold the most, and this is the lowest sold. So you can have some data here. So with that, you can compare. If you are having something like that, you can compare. So the x-axis of a bar graph represents a discrete category. So what category it belongs to? For example, if it is, or otherwise we have months, right? For example, if you are comparing 4 months, so this is January, this is March, this is December, this is February. Okay, you can do like this. This will be the name of it, and this is the value. Y-axis is the value. So what is the use case when you want to display data that are grouped into discrete categories and when you want to compare differences among the category? Regarding the multi-line, for example, if you want to compare and see both of it, okay, what different things you can go and draw this. So how are we going to draw this? We'll see in tomorrow's class. Today I am telling you about what are the different type of graph and when to use it. And next will be pie chart. So a pie chart is a circular graph that is divided into slices. So it represents the relative size of different categories in a data set, and the size of each slice is proportional to the percentage of the total. So it is like a total in 100%. For example, this will be a 40%. Okay, this is 30, this is 20, then and that way. Okay, this can be helpful for highlighting the largest and smallest category. If you want to perform like this will be the largest, right? Even without seeing the point, you can actually understand from this. So this red one takes the majority of the part, and then these two, and then this one. This is the smallest. So for comparing this, you can go with pie chart. And if you are having multiple things, then you don't want to go with pie chart because it will be like different colors and you won't understand anything from that. And next is heat map. And if you guys remember, when we see about pandas in yesterday's class, I told you something known as correlation. What is a correlation? How one column is related with other column, and we got it with the help of .corr. So it will take the numerical values, the column will be there and the index will be also be the columns, and it is going to cross check and it is giving you the positive correlation or negative correlation. In that time I told you we are going to apply that in a heat map. So otherwise you can pass it in a heat map to visualize the table actually. The heat map are useful type of plot for visualizing the relationship between two variables in a data set. For example, to compare two. Okay, a heat map can be used to visualize the correlation between, I told you, right, that one. And correlation is just the measure of the relationship between two variables or multiple columns, whether it's a positive or a negative correlation. And this will also help you to identify pattern or trend in the complex data. So you'll understand when we see the actual graph, okay. It will be color, like based on the heat, which is nothing but the color intensity, you can visualize it. It will be like this one. Next is histogram. It is similar to bar graph, but what is the difference? A histogram shows continuous data. What does a bar graph do? Remember guys, bar graph is the discrete data. For example, if it is like this one stores 10, this one stores 20, this is 25, this is 15. If it is discrete, then it is bar graph you have to go. If you want to go with histogram, then you have to go with the continuous data only. Okay, and it will help you to display the frequency distribution. For example, if you are representing the age of people, you can go with this one. So how it is increasing or decreasing or whatever the trend is. What is the difference between them? Bar graph represent continuous data and histogram bar graph represent categorical data or discrete data, and histogram represent continuous data. And when to use it? When the data is continuous and you want to represent the shape of the data's distribution, how it is distributed overall, then you can go with histograms. Scatter plot. This will be very important, guys. Scatter plot is a plot between x and y axis. So the x will be one variable and y will be another variable. And if you want to compare, for example, the relationship between a dependent and independent variable. For example, if I will tell you a simple example. So this is like a company's data set where the x-axis is the number of year of experience, y-axis is the salary. So when we move along x-axis, if the number of experience increase, the salary also increase. Okay, the relationship between a dependent and independent variable. Okay, so that's what a scatter plot will do. It will try to plot each point and you can find a trend whether it is increasing or decreasing. And for example, if some points are here and you saw some point which is nothing related with this, and what does that mean? It means an outlier not related with anyone. Some outlier is present. You can see it from scatter plot. It can also use to analyze trend over time. For example, you might use a scatter plot to track the sales of a particular product over time. Okay, in that sense. Next, finally, last one will be box plot. So what is this box plot? It will be in this shape. Okay, so a box plot, also known as box or whisker plot, is a useful type of plot for visualizing the distribution of a data set. This is also for distribution. When you go for histogram, or box plot, it is for visualizing the distribution of the entire data set, how it is distributed. So it can also help you identify the outlier, because I'll tell you in tomorrow's class where how to analyze this box plot. We'll be having some plots like this, and there will be a center line here. So what the center line in this whisker means, what is the middle value? So if something present in this line outer, it is a outlier. And it also helps you to compare the distribution of different data set. For example, if you want to compare the distribution of height of men and women in the population, so the center line will be the middle value, and something present here will be outlier. This will be the lower outlier, this will be the upper, and some things are there. We'll see it when we see about box plot detailedly. And in tomorrow's class is day 5. Make sure you are attending, okay? Because we'll see, you are going to see about matplotlib and seaborn with practical example of a data set. And then also I'll be giving you an first assignment, okay? You'll be circulating a link for Facebook, and we are having some Facebook and LinkedIn community, guys, where you want to post the assignment. And if you are doing it in LinkedIn, it is much more appreciable, because when you post it in LinkedIn in our group, it is going to reflect in your feed also. So if you do some task and post it, okay, these kind of things. LinkedIn is a group of all the technical people, right? So it is not something like other social media. It is for all the people like recruiters or industrial experts or staffs. So when you post it there, it will show you how you are doing your work passionately. So make sure you attend tomorrow's session. So I'll give you an assignment, first assignment on what all things we have seen till now in first 5 days. Okay. So that's it, guys. Thank you. Thanks for watching. We'll see you in tomorrow's class.